Okay, hi everyone. For our next session, we have Benoit from Paris. Benoit is the founder of Enki Multimedia, a company that builds innovative web services, and he is also the Apache CouchDB committer and Gunicorn, the author of Gunicorn. So today, Benoit is going to talk about Gunicorn, what's next, the new web challenge. Okay, on to you, Benoit.
Hi. So today we present you Gunicorn, what's next, the new web challenge, how we can handle them, and what are the new challenges for Gunicorn itself. Excuse me. So what's Gunicorn? Gunicorn is a WSGI server. It follows the PEP 303. So the last PEP that was published last year, I think, if I remember well, which is an upgrade of on the last PEP, which was 333, which was only which are made to add some extension to prepare for Python 3 and such. Gunicorn is supporting many frameworks. You can run it with Django, you can run it with Pastor, and of course with any WSGI application. That could be Flask, that could be Bottles, that could be any framework, in fact. It's used by a lot. So what I'm speaking right now are the goals of the initial project and what we wanted to do and what it is now, because the goals have mostly been achieved today. So we wanted it to be used by a lot, too easy to deploy, because me and Paul, one of the first contributors to the project, wanted the project that we can launch in a command lines in one click, in one command lines. We don't have time to fight with deployment. We don't want to fight to install what we need to know the high parameters, to know if I want to configure the prefork mod workers in Apache or whatever. And we wanted to have it used using all the standard library of Python, because we didn't want to fight with extension and package, which was a nightmare 2 years ago, and which are still nightmares, like I will explain later. So most of the goal has been achieved today. We are used by a lot. We are even used by Instagram. We are used by some parts of, if I think, Google+. We are used by Dailymotion, which is the second website of video behind YouTube in the world. And other big websites, and a lot of startups are using us. So you can find most of the information on gunicorn.org. We are now 4 developers. The last one joined us last week. We have a lot of contribution and patches, like you can see on the GitHub, and a lot of users too. So how does works Gunicorn? Gunicorn is mostly based on a primitive concept of Unix. We are using a shared socket, which means that we take a socket, we open a socket. A socket is a basic level to the lowest level to open a connection to another machine or inside the machine in Unix. So we open this socket and we share it with any process we will launch on the machine, which is different, by the way, from what does today Node.js. Node.js today does something really awful for that, to share the connection between the workers, so you can launch multiple workers today in Node.js, but Node.js is using one socket, only one. It doesn't share it, rather it opens different sockets, pipes, with the other workers, and so the data is coming first on the first socket, on the initial socket, on the arbiter, on the master, and then is sent back over the pipes, which is, like you can understand, properly inefficient. Because by using shared socket between preferred worker. Preferred worker are OS processes that we launch with code on it. We are using the natural load balancing that does the systems. So to explain better, I made a schema. So basically, you have the connection coming on the socket. The system offers a backlog. A backlog is just a queue of the connections. So the connection will first go in the backlogs, and they will be processed by the worker in a round-robin algorithm, basic round-robin algorithm. So here, I don't have the remote. So here you have the connection coming. You have all the worker saying to the systems, I am accepting connections, and if one is available, the system pass the connection to the worker, and then drop the other workers, and the other worker will have the other connections. You can do it in Python very easily. The socket module of Python is pretty complete today. We are using bind and accept instead inside, and we are using OSForks to open a new process. We could have used the module multiprocessing, but for different reasons we didn't do that, because multiprocessing module is pretty cool if you want to launch one worker, launch some calcul on that, and get back the results. Eventually share the results between the workers using C types. But what you can do in multiprocessing, you can't make sure that your process is still running. It does somehow behind, but it doesn't warn your system that the worker is dead. You will know it with the result behind. You can't. It does a lot of magic behind to create the worker, and we wanted a short code, very simple, that we can reuse ourselves and maybe hack on it better. So we just use the OSForks primitives. Beyond Gunicorn, because so right now we have a system to accept connection, to pass it to workers, but now we also want a way to control these workers and to control Gunicorns. So we can do it like some does by using RPC commands, using 0MQ, HTTP, or whatever your supervisor wants. But we wanted something simple too, again, and we wanted something Unix-based. Again, and in Unix you have something really awesome, which are the signals. So signals are a way to notify any process in your systems, saying to him, I want to kill you, I want to upgrade you, I want to that you exit cleanly, etc., etc. So you have a lot of signals, 12 I think, in the system that allows you to communicate between process in a very easy manner. And because this is a signal system, in a signal you have the concept of events, so you can send signals and wait for the feedbacks for the signals very easily. So for example, in Gunicorn, if you want to upgrade your code, you upgrade your code of applications, and you want to put this new code online without killing the other worker, without killing the old connections, the connections that are running with your old codes. So you can simply send up signal to the master, and it will gracefully kill the workers. It will wait that they are finished with the connections, and kill them and replace them with a new worker that contains your new code. By doing this, you have just like Nginx does or some Erlang applications, you have put your new code online without without shut down the application. So your service is continuously running. with the signals, you can also dynamically manage the number of workers. So if you can start with the rules, it's say in Gunicorn is saying that you start the number of workers plus 1. But if you find that you need more workers for any reason, because you want to handle long connections, long calcul in your worker, so you increase the timeout, etc. So you can just send a signal to the worker, to the arbiter, which is a TT-in signal to increase the number of workers and TT-out to decrease the number of workers. I said things in this order. So Gunicorn is managing for you dead workers. So in Gunicorn, you have a timeout of 30 minutes by default, which is a timeout in between we test if the worker is still active, has answer to him. We do that by opening a temporary files. Each time we open a new worker, you have a new temporary files that we remove from the file systems to not leak the file descriptors. And continuously, each second, the worker will update the files. It will just change its modes to change the date of the files, and continuously every 1 millisecond, 1 millisecond, the arbiter will check if the file have been updated, and if the file have not been updated since 30 seconds, the default timeout, it will kill the worker for you. So you won't have that process running on your systems. You can of course increase this timeout if you want, but this is not recommended. In Gunicorn, so you have the base of Gunicorn is how to manage process and to share the connection between processes. We have our own HTTP parser to support WSGI. We have made third iteration of the HTTP parser to have something fast. If some will ask me why we are not using an HTTP C parser for HTTP, so we tried the one from Doriant using Node HTTP parser. We tried the one from Zetshow, which was in Mongrel, and which is in Mongrel too, I think. But we wasn't convinced that the extra rapidity we have in the parsings was enough to handle all the edX that give you the installation of a C extension with your code in Python. And for some system it won't work at all because you are not you don't have the C extensions installed on your system, on some system. So this is the third iteration. We are working on the fourth iteration to make it faster, basically using most of the new I/O stream API in Python, which will help us to make things a little faster and cleaner, I think. I said we support all the WSGI specifications, but we have also some extensions because the WSGI specification by itself doesn't say anything about chunk and header. In Gunicorn, we are streaming everything from the client connection to your applications, so we don't keep anything in memory to keep the memory, the usage of memory very low. And basically, the WSGI specification doesn't say anything about chunk and encoding or stuff like it, so we have to hack around. Today, there is also a need for Websockets or any other protocol that you want to add in your applications. So again, the WSGI application proposed to have some kind of file objects to get the input from your sockets, from the client sockets that you have in your environment object in WSGI. but this isn't enough. If you want to play with WebSocket, you don't want to play with the Fly object. You want to play with the socket directly and take the socket at some point and discuss directly with the client to keep the connection alive. So what proposed Gunicorn, and which is also proposed by CherryPie and others, but there is no real specification about that. We have added a socket parameter to the environment, so you can just keep this socket from the WSGI environment and use it in your application for WebSockets or SPDY or whatever. Which also means that you can eventually monitor the sockets with your own application before going back to Python. If send file is available, so send file is an extension on Unix that allows you to send the system to keep the socket and send the file from the file system directly to the socket without having to use WSGI and to use the file object in Python, etc., and the extra parsing that it needs. So if send file is available on your Unix, on macOSD, on FreeBSD, on whatever, we are using it. We have also a logging model. This logging model exists. This is a wrapper around the logging module in Python. We are using a models to allow the re-exec to handle the to be short. When you reload a worker, it will generally lost the file descriptor to your logging files. So we have to re-exec the logging files, file descriptor, to make sure that it's still shared and that you can still write on it, and so it won't impact any other workers. So we have met, and you have also the possibility to log any access to your file using these extra models and the logging access config file. Gunicorn is easily hackable. You can provide your own workers or logging class if you want, using the plugin system of acceptance tools, which is very problematic. I will explain later for us, because today in Python 3 there is no real specification about plugins, and apparently some doesn't want. There is one, but basically we will need that soon if we want a real Python 3 support. So what I presented you is what we call the synchronous workers. If you remember the schema, so you have the connection coming to the backlog, and then the connection is gracefully balanced to one of the workers that is accepting connections. In synchronous workers, in sync workers, you are limited to the number of workers. To the number of concurrent connections are limited to the number of workers. So if you have 3 workers launched, you will have only 3 workers at the same time used by you will have same 3 connections processed at the same times. So we advise you to use a buffer to proxy connection, proxy to buffer connections behind, like this. So you add a proxy on top, a proxy that is able to buffer. Today there is only two that can do that. There is one Nginx that does that naturally. So if you have the buffer function enabled in Nginx, you can buffer the connection to Gunicorn. By buffering the connection, it means that Nginx will keep the connection open behind, and when the Gunicorn becomes available, when the backlog is not full, it will send a new connection back. So it will give the impression to the user that you can have 10,000 connections at the same time, which works pretty well. Instagram is only using the sync worker. Some big service, Dailymotion, is also using the synchronous workers, and it's able to handle 1 million and more customers a day just using the synchronous workers. So does it scale? Yes, on a certain limit, of course. If you start to use external API or some longer code, like writing a file on your systems, or if you want to do a lot of calculus when you get a connection, it will have for results that your connection will take times, and Gunicorn will think that your worker is dead, and will just kill it, which will drop the connection with the clients. So you don't want that in some applications. So does it scale? Yes. So you can use a proxy to buffer the connection, or you can use asynchronous workers. So the current asynchronous workers supported at the G-Event one, or working with the G-Event library, G-Event-led one, Tornado, working with the libraries with the same names. In external workers, you have MineHealth, which is done by a guy from here. Is using also greenlets like G-Event and eventlets, but I've built a lot of code in C using the HTTP parser from the Giant, etc. And using EasyIO, another, I'm not sure if this is the right, PicoF, which is another library to handle event loops, where G-Event is using libf today. You have also the workers around. There is one on a branch of the Gunicorn using Twisted that we don't want to support for some reasons. And there are others that you can find on the web using different systems. So how does it work an async worker? So basically, so you have still your free workers, but rather than having one connection per worker, you will have a multiple connection per workers. So again, you can set using the settings command lines the number of concurrent connection you want to, in the workers. By default, this is 1,000, if I remember. So if you want to handle 10,000 connection to answer to the 10 cap programs, you will have to increase either the number of workers or the number of concurrent connections you want in one worker. Just as a side note, this has handling concurrency in your application like this have an impact on the memory usage, of course, because since you will handle more connection by workers, you will handle more memory by workers. So don't be surprised, or don't say on beginning is so I see that your memory increase because you use G-Event or eventlets. This is quite normal. So you have this connection handler, and to give the final figure, so you have that. You have the connections coming to the socket backlog, to the shared sockets. Then it's load balanced by the system of the workers, and then you can handle multiple connections in one workers. So what it does, when a worker accepts a connection, it spans a new process. It could be a green process in G-Events, greenlet, or in the case of Tornado or Twisted, it just wait on events and pass to the other events, the connection. You have some paper about that later. So all asynchronous workers are for now based on event loops, reacting on input-output events, read and write on the sockets, with different APIs. So what is an event loops? This is basically a message passing patterns. So you have someone sending a message and multiple person waiting for message. The one that the first one we take the message comings, and then it loops again, process a message, send a message, etc., etc. Which is for input output. So you have the connections coming in the loops or registered in the loops, and when there is a read event, the loop will send back to the program, and again for a write program, etc. So you basically, what those asynchronous workers are registering callback in the event loops. You have two kinds of API in Python. The asynchronous API based on callback which is handled by Twisted and Tornado, which means like just like in Node.js or Node.js do just like in Twisted and Tornado. So when a write event happens, you have a callback handles, and you take the code, send it back to Twisted by generally by writing to the socket, by sending a file, etc., or an answer, and it will create a write events, go back in the loop, etc., etc. G-event is based on the same process, but it proposes you an asynchronous API, a synchronous API. So it means that if you do a socket resaved, it will just work like this. You won't have to set up yourself a callback and forget sometimes that you have a callback here that you should handle, etc., etc. This is basically a synchronous API that blocks an event at the same time the program, pass the command to the loop, and wait until the loop sends a callback. So to take the example of G-events, how does it work? So it's based on greenlets. Greenlets are mostly coroutines allowing you to interrupt the functions. So when you say to your function switch, it will just interrupt the code and pass the code to another greenlet and other coroutines. There is no scheduling inside, so you can handle the scheduling like you want. And the event does that by placing callback to this function in the event loop and switch. So for example, on the socket we saved, it add an event to the loop to react on read, because you want to know when the socket will be will have some data on it. The read callback is switch back to me and continue the code. So when you switch back to me, I will, in the case of socket resave, I will return the data that I resaved, etc. And when you have set the callback in the loop, you switch to the greenlet on the event loops. So yes, there is a process always running, maintaining the event loops, and it switches to the event loops, greenlets, allowing it to handle the new switch. So if we go on the event loop, the event loop will wait, and once there is a read events, it will send it back to the code. And you switch from time to time. So when you span a function in G-event, what you effectively does is not spanning like in greenlet words. You have set up a callback in the event loops, waiting when the event loops become when the event loop become available, and when the event loop is becoming available, it's sending back to your code, which has many caveats, in fact. So a function that will take times in your calcul, and you will block other greenlets during these times because no one is running, the event loop is not running. So it will block all other greenlets. So either you make your function very fast and set it back to G-event, or from time to time you can use the G-event clip with 0 seconds passed to it, or none, I think, to switch back to the event loops. When the event loops become again available, it will go back to your client's codes, and you continue the client code. For example, if you get the data from the sockets and want to write it on the file systems, it's good from time to time to add a G-event sleep. So do a write on the file system, sleep, go back in the loop, on the resave loop, read the data, write, sleep, etc. So it will let the possibility to other process in your application to run. And in the last possibility to when we have very long tasks, for example, maintaining a socket to your database, or I don't know, having whatever that will take long and that we want to keep apart from the schedulings done by the event loop in G-event, you can open a thread pool. You can open a thread in the thread pool offered by G-event to handle the long connection. Okay, that's for the events caveats. So today Gunicorn is working on 2.7 or 2.5 to 2.7. I think we removed 2.5 recently, so 2.6, 2.7 version of Python. We wanted, of course, to have it working on Python 3. So we have made many branches working on Python 3. We had a lot of problems with each one. We had a lot of problems until Python 3.2 versions because a lot of API wasn't very stable. Basically, our main problems are that in Python 2 versions, you have two string types. You have Unicode and string. And in Python 3, they switch to bytes and strings, which is a good idea. So bytes are basically bytes, and string are Unicode string, or they all on Unicode, basically. So we have to handle that in Gunicorn without losing too much in the rapidity to parse the HTTP. We tried a lot. We tried the 6 API proposed to handle byte and string. It doesn't work so well. We tried our own wrapper, which is the current case in one branch. It works. Not convinced this is a good idea. I think the good idea will be to revamp our new HTTP parser and use the new IO API in Python 3, which is also available on Python 2.7 and with some small change available in 2.6. The small change in 2.6 is that when you want to resave your data from a socket to save it in the buffer, it doesn't work on Python 2.6. It doesn't accept byte array. So we have to make a change to have it working. So this is really a nightmare, and we try a lot passing to Python 3 while keeping the Python 2 versions and without having two separate branch, complete separate branch, is really a nightmare. So we don't want to have two separate branch. We don't want to have Python 3 and Python 2 version because the main goals behind that is to force people to go to Python 3 so we can remove when 2.6 version will become not stable. We will remove it, and the same for Python 2.7, and we hope that it will help people to go faster on Python 3 by just having one version to use in their code. The other problem that we have is the lack of public plugins in distutil 2. So in distutil 2, you have today a metadata database that allows you to store any metadata from your package in a database, and you have some API call that you can make to question this database. So if you want a plugin is, for example, if you want to create your own G-event worker or your own worker for Gunicorn. For now, what we will do is to saying to setup tools, I want to advertise Gunicorn that my plugin exists, so I'm using a special metadata. Setup tools is storing it on a metadata database and have all the API available to handle this package. In distutil 2, they only have the metadata API, and for now, apparently there was 2 threads from Tarek, which is the guy behind the distutil 2, saying he wasn't very interested to maintain plugins. Hopefully, maybe we won't have plugin distutil 2, but I think if this is a good time to start discussion to have maybe plugin specification between WSGI application. So we don't care about the external systems used, but if we can use the same plugin system for Pastor, for Django, for Gunicorn, for any web application, it would be good. So we can use eventually distutil 2 behind on Python 3 versions and setup tools for Python 2.6 versions, etc., etc. There is a working branch, so actually two working branch. You have a Py3 branch, which is the old one. The new one is Python 3x, I think this is the name. This is Py3 anyway. So we have a working branch, but only two asynchronous workers can work on it. There is for sure Tornado, which is working on Python 3. Less sure, but I read the code recently. I think it is. Mineheld should work too, so you can use Greenlet if you're using Mineheld. Using Python 3. I think it should work, or at least the chance should be really small to have it working on Python 3. Anyway, we will have a Python 3 version working for the end of the month, and it will be released with modulo the number of workers. There may be a third workers that will be launched working with my new library follower, which is a new kind of concurrent library, but not using an event loops all the times, but using a round-robin scheduling algorithm to pass from one code into the other, just like Go, or just like Lua, or just like Rust, sorry, from Dia or Plan9, the first one. So it will be ready for the end of the month, and it will be available for all on Python 3. The other challenge that we have, a lot of people want to do today WebSocket and SPDY, and we have a lot of talk internally between developers. Do we need to add an event loops to Gunicorns? Because we can do that. We can do something like does Tornado and write something working fully in Python. But we don't want to do that. We prefer to offer a framework to launch connections over the webs, and to allow the developer to create their own worker or protocols, parser, etc., and easily integrate it in Gunicorn. It should also be easy to embed Gunicorn in your applications. So if you want to launch an application using the worker and launching something on TCP and still listening on TCP, and still using the feature from Gunicorn, checking if a worker is alive, or checking if I need to reload the code, etc., etc., etc. It should be easy to do it with Gunicorn itself. I already do that in another library I released, and which was used by Mibu, which is Pistil, which offered this API level on top of the Gunicorn engines. We would like also to make the config module pluggable, so you don't need to use always Python to handle the configuration in Gunicorn. So you could make your plugin very easily integrated in Gunicorn, which will be better rather than having to make your own code in the config modules, which is Python, and knock around it. In experimentation today, there is a branch where I experiment shared free locking counters to manage workers. So I said we have temporary files today open between workers, updated from time to time to check if the worker is alive or not. But it may be better, maybe more performance to just share a memory map between the workers and arbiters, and send an increment from time to time to these counters. So you won't leak in any file descriptors or stuff like it. So it is working. What I dislike is all the hacking done to have it working on PyPy, or to handle the non-GCC version, the GCC version that have no atomic operations available. So basically an atomic operation, if you want to update to say 1 + 1, this is not a fresh set of operations. So you have two ways to do it, using atomic operations available on your system, or using a lock. So I have to work around for versions that have no atomic operation available to use the locks, which is not so good. one worker using a thread pool for those who want to not install G-Event but still want to have concurrency in your application, so just using threads in Python. We all the drawback Python have. Listen on multi-IP, so today you can just listen one interface and one IP. Tomorrow want it to make an experimentation to listen on multiple IP, so you can easily build a WSGI middleware to handle the hosting if you want, and using only one Gunicorn master to handle everything. Code overload from the file system. When your application files are outdated, detected it and automatically reload your applications, which could be done easily today using Gunicorn hooks, but this is not integrated and not really advertised. So there is a new version coming this weekend that we have worked. Everything is in the developer branch today. That add the proxy protocol support. So I said sooner that we have two proxy available for Gunicorn, two very good proxy available for Gunicorn. You have Nginx that works very well, and you have also Asha proxy that works with the proxy protocol, which is a very cool protocol that doesn't even try to pass the HTTP, but just pass the connection to Gunicorn under the buffering, etc., etc., etc. So we have the proxy protocol support available in Gunicorn. We have timeout for client sockets. So if you don't want to run behind Nginx, etc., you can still protect yourself from the slow Laris attack or slow listening attack existing. There are fixed from logging, which basically allows your application to set up any hooks in the logging modules and have it working very well, which isn't the case today. Many other fixes. We are also moving all the docs to Sphinx and read the docs, and we have this new design for the website. And voila. Thank you. If you have any question.
ちょっと英語が苦手で申し訳ないですけど、you said that you will implement proxy support to next week only.
Yeah, the proxy protocol. Yeah.
I think proxy is very important for me because multiple server machines we have, so.そうですねすいません。ありがとうございます。そう、プロキシがあるとせっかくNginx失礼しました。Gunicornが例えばストリーミングサポートをしていたり、あとSPDYサポートをしてくれたりしても、プロキシの部分でそこが使えなくなってしまうことが今ありそうな気がするんですよね。わからない。
I think I can answer a little. The proxy protocol that we have in Gunicorn is a protocol that is started to use by some proxy, like Asha proxy. Nginx will have a module that is using it too, Apache too, HTTP too. So this is just a way to dialogue with the proxy in an easy manner that you don't have today with Nginx. For the other protocol, if you want to build your own proxy or stuff like it, we will offer the possibility to separate the transport layer in Gunicorn, basically share a socket, launch the workers from the protocol by itself. So today our workers are a little hacky, and we only handle WSGI, but it will be possible to add your own protocol behind. So if you want to make a proxy, for example, you can have one greenlets listening on the request and sending it back in a pipe fashion. So it will be possible, but not in the version coming. The version coming is just for the proxy protocol which means dialoguing with the proxy on top of Gunicorn.
Do we have any other questions?
Okay, thanks.
Yeah, thank you, Benoit.